All right, so this is one of the more complicated ones. I really shouldn't have done it first, so I apologize. But what's happening with this one is it's reflected across the line y equals x. So it's reflected across the line y equals x, which means on my graph, if I put a line right here at y equals x, everything that was on this side is flipped over to this side, and everything that was on this side is flipped over to this side. And it's kind of a complicated concept. That's probably the hardest one that we have to understand. The stretch and compression, those are fairly simple. The reflected across the y, reflected across the x, those are fairly simple. And the next two that I'm going to do are fairly simple as well. So the next one that I'm going to do is 0, -1, 1, 0. What were my points? 2, 9, 6, 6, 10, 1. So as you can imagine, what's going to happen here is when I multiplied it by this matrix right here, my x and my y switched for locations. When I multiply it by this one, that's going to make all of the new x's negative. So this row times this column, 0, -6. This row times this column, 0, -10. This row times this column, 0, -1. This row times this column, 2, 0, 9, 6, and that's it. So what happened here? If you think about the graph, what happened on the graph? We're doing a rotation, and we're rotating 90 degrees. We're rotating 90 degrees, and everything that used to be over here is now over here. So we would say that that's a rotation 90 degrees counterclockwise. We're going this direction, which is counterclockwise. So we're going to say 90 degrees counterclockwise. And I'll just run that into one word there. Why not? And it's a rotate. Rotation, 90 degrees counterclockwise. Last one I'm going to do for rotations, 0, 1, -1, 0. So remember, when I multiply this times, I'll put the matrix down here. This row times this column is going to make all of my y's into my x's. This row times this column is going to make all of my x's into my y's, but it's also going to change the sign of them. So what's happening here? Well, all of my y's that used to be positive, everything was in this quadrant, and now all of my y's that used to be positive are negative, which means it's going to be down here. So what's happening is I'm rotating 90 degrees clockwise. Now, I'm not going to make you guys remember all these rotation matrices or reflection matrices, but what I do want you to be able to do is actually find the new points or the new shape and tell me what happened. If you can remember them, it's going to just make it faster for you, okay? The very last thing that I'm going to do, similar to something that we did before, is I want you to move this 4 units to the right. So how would I move this 4 units to the right? I want all of these to get 4 bigger. So how do I only add to the top without adding to the bottom? Well, I know in order to add to a matrix, I need a matrix that's the same shape. I want all of these to be 4 units to the right. So I'm going to add 4 to each of those. I don't want these to move, so I'm going to add 0 to each of those. And that's how I'm going to move it 4 units to the right. So I'm just changing the x's, not changing the y's. What if I wanted to move it 2 units to the left? 2 units to the left means I just want to move that to the left too. So I'm going to add to it -2 to each one. I don't want to change these, so it's going to be 0. And the very last thing that I'll ask you to do is something like this. I'll tell you, what changed? What is the change to the to the points, to the figure. And all I want you to do is tell me it went to the right 4 and up 7. These are getting added to these, so that's moving them up. Hopefully that makes sense.